Now that we've gotten a lot of the introductory material out of the way in the CCDA series, it's time to have the rubber meet the road, as they say. It's time to really get into some awesome network design concepts. You're going to love this particular lesson as we look at making it modular. What are we making modular? We're making information technology modular, and we're going to focus on just how impactful modularity can be when we're designing a network. What is modularity all about? It's about designing the network in chunks. Sure, the chunks are going to be interacting with each other, but if we focus on these chunks as we design the network, we're going to find that we can really implement a design that meets the needs of an organization head on. So, what are we going to cover in this Make It Modular module? Oh, terrible pun, sorry. We're going to take a look at three things. Now, I'll tell you, the first thing that we're going to look at is by far the most famous design model that Cisco has ever created. It's called the hierarchical network model. And do you know that it took me at least a decade to be able to say hierarchical? So we have the hierarchical network model that we'll look at. This is a three-layered model that you're going to love. Next, we'll look at the Cisco network architecture for the enterprise. That's right, Cisco says, look, we'll give you an example model that would fit almost all networks out there today. Wow. So we'll take a look at that model and we'll see again how very modular it is. And then we'll take a look at infrastructure services like voice over IP and security and wireless. And we're going to see how we can take a modular approach to the design of those network services as well. The hierarchical network model is a network model that we can apply to just about any aspect of Cisco technology, it seems. It consists of three layers. So your first task is to make sure you master the three layers. They are access, distribution, and core. Now, what is tricky about this is that a lot of different literature likes to be creative and call these different layers by different names. For instance, you might see access as desktop layer, or you might see access as workstation layer, or even workstation access layer. So you'll see lots of variations on these names. Why the variations on the names? Well, as I indicated, the hierarchical network model can be applied to many different technology sets. So if you're talking about a PC type of environment, you would call it the workstation or desktop layer because that's where those devices are located. But if you're talking about the router hierarchy within an organization, well, then that wouldn't make much sense to call it the desktop layer because there are no desktops when you're applying this model to, let's say, how your routers are organized. The distribution layer will often be called the policy layer. And this is because this is where we're often doing security policies, for example. And then the core will often be called the backbone. So it really would behoove you to know the classic references. What are the classic references again? Access, distribution, and core. But it would also do you well to realize that these are going to be referenced by slightly different terms. Now, as we'll cover each layer, I'll give at least two examples because we said these three layers can be applied to a lot of different circumstances in information technology. So the first example I'll give of the access layer is a PC-based LAN type of environment, right? We said it can sometimes be called the workstation or desktop layer there, and that's because this layer is obsessed with that PC making a connection onto the network. And that is often through an Ethernet connection, and then they plug into a layer 2 switch. So, in the example of the local area network within your organization, this is the stuff of the access layer. That Ethernet cable, that PC, that layer 2 switch that gets them on the network. If it's a big LAN, they may even connect to another layer 2 switch. And these are the things of that access layer. Now, what if we're talking about a router hierarchy within an organization? Well, we're talking about an initial router, let's call it R1, that is accepting information and then passing that up to a router maybe called the distribution router. You see? And this may be a small, lower cost router, and this is a larger, higher cost router at the distribution layer, a more sophisticated router. So we can say, all right, these initial lower cost routers are at the access layer of our router hierarchy. We're of course talking about a LAN in this case, and we might be talking about a WAN in this particular case. So the access layer, obsessed with that initial access into the network infrastructure. Now, what about the distribution layer or the policy based connectivity layer or some other fancy descriptive term? Well, let's go back to our PC at the access layer, connecting to a switch and then maybe connecting to another switch. And that's all at the access layer. And now they connect to some big fancy router. This is the demarcation point. This is the distribution layer. And notice this device is going to send their information somewhere else. By the way, in a lot of networks, this device may be a fancy multi layer switch. So I'll just say a layer 3 switch. There's a lot of variety, obviously, in the devices you can find at the distribution layer. At the distribution layer, we have a lot of overhead. I mean, this is where we're typically doing quality of service, security. Obviously, we're doing routing, maybe even policy based routing or optimized edge routing here. So, this is where we have a lot of stuff going on that might add some overhead to the equation. Now, in our WAN type of environment, we already kind of gave you the example of the distribution layer, right? We might have some access layer style lower end router, and it connects to some fancy distribution router that's doing all that kind of horsepower work. You know, the QoS, the security, the optimized edge routing, all that fancy policy based stuff. So, that, my friends, is the distribution layer. But what about the core layer? Well, in real estate, they say there's three things that are important: location, location, and location. Well, at the core layer, there are three things that are important: speed, speed, and more speed. Yeah. Let's look at the LAN example. We have that distribution layer router. It's going to feed data into the core, where we usually have really fast multi layer switches moving the data around as quickly as possible. So in the core, it's all about very fast devices. It's all about speed, speed, speed. We might do a little QoS, but that's about it. I mean, we don't want to do a lot of security in here. I mean, why do a bunch of security overhead in here if you've made sure the data is secured at the distribution layer? So in the core, we emphasize speed, speed, and more speed. In a hierarchical WAN, we had that distribution layer router. It's going to be feeding into a core router. Cisco actually has this internal slang they use for these routers that you might find in a WAN hierarchy in the core, and it's really inappropriate what they call them. Yeah, they call them BFR. R's. And this stands for big, this stands for router, and I can't say what the F stands for because this is a family show. So that gives you the idea of the complexity and the speed and the horsepower of these devices in the core layer. Now, let's turn our attention to the network architecture for the enterprise that I promised you I would tell you about. Cisco has this overall blueprint that they say is so well thought through that you could apply it to just about any organization. Cisco also says that it's modular, and we love to work on things in chunks when we're doing a very complex design. That concept, by the way, really has to do with like you building a house, right? When you build a house, it is a very complex process. And you do it modularly. You do the framing of the house, and then you can go ahead and do the electric of the house, and then the plumbing of the house, and you focus on modules. And I'm about to embarrass myself with my lack of knowledge of building a house, which is especially painful for me since my father builds houses. But, anyways, all right, so this network architecture for the enterprise, here's the thing. If we were flying in an airplane 30,000 feet above the surface looking down on it, we wouldn't be able to see the details of it. We could just see like three big land masses. Actually, four big land masses. What are they? Well, we see a big landmass called the campus, a huge module called the campus. And then we see a big landmass, a huge module called the edge. And then we see a module smaller, but it's called the service provider module. And then an even smaller module, but we can still see it, and it's the remote access module. So in the network architecture for enterprise, the three big chunks are campus, enterprise edge, as it's often called, the service provider module, and the remote access module. Now, guess what? We don't just deal with four modules when we design a network. Inside each of these is going to be additional modules. So what I want to do right now is I want to go ahead and I want to focus with you on each of these major modules of the network architecture for enterprise and show you some of the stuff that would be inside each one. When we look inside the enterprise campus, guess what we're typically going to find? An access module. Yeah, a distribution module, a core module. We may even have a data center module inside the enterprise campus. Wow. So notice we break it down into these modules. And by the way, for something complicated like a data center, you may have a different design document that breaks down that module. And guess what? It's often broken down into access, distribution, and core inside the data center module. So I think you're really starting to see just how modularity is going to assist us. And also, you apply the network hierarchical model to these things, and you realize, well, in here we have layer 2 switch concerns and their design. In here we have maybe layer 3 switches and their design. In the core, maybe it's those BFRs from Cisco or really big layer 3 switches. And then in the data center, you have these concerns. So doing it in a modular fashion is not only easier for you to pull off as a network designer, again, it's typically going to make the best design possible because you can really focus on layer 2 switch best practices, layer 3 switch best practices, and these really big router best practices. Now, what goes on in that enterprise edge landmass that we looked at down upon from the airplane? Well, we have the e-commerce for some organizations. We have the internet. I think most organizations need internet connectivity. We might have virtual private networking chunks in here. Our own private WAN might be in here. And now we start to really come upon another aspect of this. Cisco says, look, this is an overall modular design that you should consider for your organization, but you're not going to need all of it. I mean, there's going to be some organization out there, some mom and pop shop that says, we are never selling on the internet. We are never, ever going to sell on the internet. We are never, ever engaging in e commerce. I think that's silly, but they may say that. So we're going to pick and choose from the modules that Cisco suggests as we go about the design to once again meet the needs of the organization. Now, these modules interact. I wanted to break them down like this so you really were educated about them, but I also want to just remind you quickly, and I'll just do it this once, that obviously these big chunks interact. What was over here? Over here was that enterprise campus, right? And inside of it, like the distribution block. Well, remember, the distribution block is going to have to interact with the internet block that's in the enterprise edge. So even though I'm teaching these to you separately so you can really have laser focus on them, please keep in mind that there's obvious interactions we have to worry about between these different major modules. What about the service provider major module? Well, for some organizations, they don't just trust ISPA. They also go ahead and have a module dedicated to ISPB. In fact, if I ever start an ISP, I think I'm going to name it ISPB. But anyways, maybe they have some crazy kids that are still dialing up using ISDN, or boy, what if they're dialing up using an old-fashioned modem connection? Yeah, so there might be a public switch telephone network block in there. You get the idea. This is where we interact with service providers. All right, and I will mention it again. Remember the enterprise edge? Remember the enterprise edge had an internet block? Obviously, we're having the interactivity once again between these major modules. Now, the last major module that we showed there was the remote access module, and in there we might have a remote data center. So we have a block dedicated to the remote data center. We might have a bunch of teleworkers. Yeah, those lucky folks that never leave their house. They work from home. So we have a block dedicated to that. This major area, for some organizations it would be rare, but this major area might not exist even. So remember, this is all a network architecture model that we pick and choose from. And the complexity of a data center block, let's say, in the remote access might be minimal in one organization compared to the data center blocks of remote access to another organization. Can you imagine that little company named Google? Can you imagine the complexity that goes into their remote access data center, their campus data centers? I mean, they'll have a massive modular blueprint just for one of their data centers, where for another organization, it is just a server closet. So, the remote access module, once again, providing us a blueprint of possible modules that we can lay out. Now, what's amazing is that we can even approach the services, the infrastructure services that are in the organization in a modular fashion. What are some of those? Security, pretty important. An area that we can call IP communications. An area of wireless, right? That's a great service that a lot of organizations are going to want to take advantage of. Application networking services, what in the world are those? We'll show you. And high availability. So in the CCDA, we cover these 5 infrastructure services. And In more advanced design classes, you might even take on more, but these five, I'm sure we all can agree, are critically important for most organizations. Let's take a look at each, just like we did with the enterprise network model. Let's go ahead and look at each of these and see how we can break them down in a modular fashion. When it comes to security, we need to break this down at least into two main blocks, and that is internal and external. It's amazing how many organizations focus solely on the fact that they have what's called an open network, which means it makes connectivity to other networks like the big scary internet. And because of this open network architecture, all they focus on is external attacks. They're just convinced that if there's a security breach, if there's a denial of service attack, if there's a reconnaissance attack, if there's an access attack against their organization, that it's going to come from the outside. It's going to come from a terrorist. It's going to come from a hacker, a phreaker, a cracker, all these different terms for all these different people that might attack us. They're obsessed with the fact that it's going to come from the outside. They forget that about 70% of all security breaches come from within. Disgruntled employees, curious employees, even happy employees that just want to see what they can do. I guess that's a bit of a stretch, but you get the idea. All kinds of attacks come from within the organization. So we have to do due diligence to that particular category. In fact, it might get an ongoing greater emphasis than external attacks. Now, when it comes to the world of IP communication services, this one's easy. We break it down with data, voice, and video. Now, again, look, your organization might not be doing anything with video over IP, for example. So you're not going to have that module. And by the way, once again, remember the complexity of your service implementation can dictate if you break these modules down further. If you look at voice, for instance, your company could have a very simple, kind of small business edition type unified communications presence. No big deal. No need to elaborate on that particular block. But your organization may be taking advantage of every single voice product Cisco ever considered. And if that's the case, then you'll have this voice over IP structure that has all kinds of components inside it. Notice how all of these IP communications have different requirements, right? Let me just real quickly give you an example. Data is what we call bursty in nature, but it is latency insensitive typically. Okay, so I'll just put no issues with delay. Now, again, there may be some exceptions inside that data block, but notice how different that is from voice traffic. Voice traffic, we say, is benign, meaning it's not bursty, it's smooth, it's just kind of harmless on the network. It's not gonna it's gonna be at a pretty steady rate. But of course, delay is a major issue. So we need to break these services up modularly because they have some pretty dramatically different requirements. How about the wonderful world of wireless? Yeah, seems like organizations want to take advantage of this to differing degrees. Once again, some say, nope, not coming near this network. There will be no wireless here. Other organizations are saying, we want it throughout the entire organization. Everywhere you go, you should be able to connect with your wireless device and take advantage of that. So, lots of variety here. Most companies can break this down as follows. The wireless endpoints. Yep, that's a major category. Of course, what everybody thinks about, the wireless access points. the wired infrastructure, and then I ran out of room. How about a block right here? WLC. What is WLC? A wireless LAN controller type block. What tools are we going to use to manage the wireless infrastructure? In Cisco terms, this is called a wireless LAN controller. If you're dealing with some other vendor, it might be termed something else, but I think you get the idea. Where is going to be the equipment and how will it be designed that's going to be managing the endpoints, that's going to be managing the access points, that's going to be managing the integration of the wireless to the wired network? Now, network services have become so important for organizations that we have a category of services that we call application networking services. So, what we're talking about here is things like here's a block: optimization. You know what might go in here? Cisco web caching services. Yeah, devices that are going to dramatically speed up web browsing, because we know web browsing is such a critical component of organizations, most organizations today. For some organizations, web browsing actually detracts from the value of the company. How about load balancing? Yeah. How about services that make sure we distribute the load equally between different file servers? Again, tied into optimization, of course. How about things like messaging services? Yeah, a lot of organizations are relying more heavily than ever on all kinds of messaging applications for employees to communicate. So, this is another category called application networking services, and there are many potential modules here. And then another important category: high availability. Yeah, we want to make sure we get that at least 5 nines. I say at least because, again, we're looking at 7 nines today, 8 nines, 9 nines. I mean, we are trying to just increase availability like never before because the network is more important than ever before and people come to expect it. I mean, YouTube is always up from Google. So how come our network can't always be up? I can always get to my silly kitten videos. How come our network doesn't provide the information I need when I need it? Common areas that we divide this up in are routing. Yeah, high availability in routing. If we can't go through one service provider to get there, let's go through another. Those kind of issues are combated with alternate paths through the network. We also like to talk about high availability with connections. Yeah, and this has to do with technologies like spanning tree protocol. We have switch 1 at the access layer. It connects to switch 2 and switch 3 at the distribution layer, let's say. We got to make sure there's redundancy in those connections so that if there is the loss of a connection, that we can still communicate. And we need things like spanning tree protocol to make sure that this redundancy doesn't cause a loop within our network infrastructure. And then obviously high availability has to do with the network itself. Now, when you talk about high availability in the network itself, I like to break this down personally into two categories I've always used: high availability redundancy inside each device, and then redundancy between devices. Okay, so we think about a big multi-layer switch from Cisco, and we have redundancy inside it because there's two power supplies, for example. And then we take care of redundancy between the devices because we have another one sitting right next to it. So you see how we can do that? There's redundancy for high availability inside devices, and then, of course, we have redundancy between devices as well. How much high availability that you can build into your network infrastructure is going to directly depend on two things: the expertise of your IT staff for doing high availability designs, and also, of course, budget. Can you afford two power supplies in your fancy multi-layer switch? Can you afford a second redundant multi-layer switch? These are obviously concerns when we're designing high availability services. So, in this important CBT nugget, we took a look at that remarkably popular hierarchical network model from Cisco. We remember the access layer, the distribution layer, and the core layer, and we remember how we can apply that to many different network design type models. We took a look at a specific network design model from Cisco called the Network Architecture for the Enterprise, and we even took a look at how we can modularize infrastructure services like security and voice over IP and wireless and high availability. I hope this has been informative for you, and I'd like to thank you for viewing.